Let's consider the following problem. Douglas scored 87 on his last math test. The average on the test was 79 and had a standard deviation of 6. Elizabeth scored 75 on the following math test. The average on this test was 65 and it had a standard deviation of 4. The question we want to answer is, whose score represents the better score relative to the rest of the class? Because each test has a different mean and a different standard deviation, we cannot just look at the raw scores of 87 and 75 and say that Douglas did better. We need to look at the z-scores for the two different tests. Recall that a z-score tells us how many standard deviations above or below the mean a particular data value falls. The formula for a z-score is the data value minus the mean divided by the standard deviation. So let's compute Douglas's z-score for his math test. He scored an 87. The mean on his test was a 79 and the standard deviation was 6. This gives a z-score for Douglas of 1.3. He scored 1.3 standard deviations above the mean on his math test. Now let's compute the z-score for Elizabeth. She scored a 75. The class average on her test was a 65 and it had a standard deviation of 4. This gives a z-score of 2.5 for Elizabeth. This means that Elizabeth scored 2.5 standard deviations above the mean on her test. Comparing the two different z-scores as opposed to the raw scores on the test, we see that relative to the class, Elizabeth did better because her z-score of 2.5 is greater than Douglas's z-score of 1.3.